In this video I'm going to try to explain exactly what the mechanics of confidence intervals are. The point of confidence intervals is to construct an interval that we are confident contains the parameter we're trying to judge. In the AP course, this is always the observed sample mean or the observed proportion or something like that. Suppose we take a sample of size 50 from a population whose mean mu is unknown, whose distribution is unknown, and whose population standard deviation is sigma equals 16. Even though we don't know anything about the underlying population, because n is large enough, we can conclude that the observations of the sample mean should follow a normal distribution. In other words, the sampling distribution of the mean will be normal, with a mean mu and a standard error of the sample mean being the population sigma over root n. So, in other words, the sample mean should come from a distribution whose mean is the same mu as the original population mean and whose standard error is sigma over root 50, which in our case is 2.263. In order to calculate the interval, we need to go back to chapter 2, the normal distribution, and try to figure out what numbers we need for the 95% symmetric interval. So if we have any normal distribution and we want to find a symmetric interval which contains 95% of the data, or in other words 95% of the observations should lie in this interval. If there's 95% in the middle and it's symmetric, then there is 2.5% in either tail. So we look up either phi to the minus 1 of 0.025 or for the top tail phi to the minus 1 of 0.975, 2.5% above, so 97.5% below, and we find out that the magic number for this is 1.96 and minus 1.96. So 95% of all observations of the normal distribution lie within plus or minus 1.96 standard deviations of the mean. In our case, 1.96 standard errors is 4.435. That means whatever's going on with our population mean, we know that 95% of the values should lie within the true mean plus 4.435 and the true mean minus 4.435. 95% of all our observations should lie in this interval. This interval captures 95% of all observations. So, if we construct this same interval around our observed sample mean, suppose we have our observed sample mean there, and we construct plus or minus 4.435 around it, or perhaps it lay here and we construct plus or minus 4.435 around it, then both of these will create an interval which captures the true mean. Now, occasionally we might get a fluke observed value which is way out in the tail. It's not a bad value, it's just not one of the normal nice 95% values. And if we construct that same interval plus or minus 4.435 either side of this one, then it doesn't contain the true population mean. So a confidence interval for the true population mean is simply the observed value plus or minus 1.96 standard errors of the mean. And what this does is say this interval should capture the true mean based on the fact that 95% of the observed sample means will be in this nice area. So assuming that we have a 95% chance of getting our observed mean in this nice area, then this interval will capture the true mean. We are 95% confident that an interval constructed in this manner contains the true population mean. And you must use that vocabulary. We are 95% confident that an interval constructed in this manner contains the true mean. It is absolutely not saying that we are 95% certain that this interval contains the mean. I know it's technical, I know it's slightly confusing, but the proper terminology is we are 95% confident that an interval constructed in this way will contain the true population mean.